In this video, we will discuss quantitative data for sampling distributions in AP statistics. So we are still in Unit 7, and we are talking about this idea of quantitative data and creating sampling distributions or using sampling distributions. So the reason we like to talk about repeated means or repeated averages from our samples is because it provides a more normal shape that's less variable. And when your data is less spread out, it gives you a more focused and accurate set of data from which to find probabilities using the normal curve. So that's why we use that. So again, just like I talked about with proportions, we want to talk about this idea of a parameter versus a statistic. So of course, the letter mu represents a measure from my population. So your population parameter is referred to as mu, and your sample statistic, which comes from a measure of a sample, so your sample statistic is known as x bar. And of course, just like we did with proportions, we are going to estimate our population parameter with our sample statistic. Groovy. All right, so let me reiterate this. I've already talked to you about this some, but we need to talk more about this idea. When we create our distribution with every possible sample of a given size, that's what creates our sampling distribution. And that just tells us that when I create that sampling distribution, if that sample size is big enough, then it's going to be representative and it's going to do a good job of giving me a normal distribution when I create that sampling distribution. So what do we know about a population that is normal? Well, if we have a population that is normal, then what happens is that regardless of the sample size you take, the sampling distribution is also going to be normal. So no matter what size that sample is, if you are sampling from a population that is normal, you will get a distribution that is normal when you take that sample. Okay, so but there are many times when your population is not normal. So what do you do in that instance? Well, guess what? You can make up for that with this idea of creating taking a sample that is large enough. If it's large enough, then it will be approximately normal. And of course, we need to seek the answer to this question. Well, how large would be large enough? Well, there's this idea here that when you are talking about is it a large enough sample, you are talking about at least 30. Okay, so if you'll notice, I skipped some stuff in the notes. I want to talk about our conditions for just a moment for quantitative data. Just as we did for proportions, our conditions are necessary to say that we can approximate with the normal curve. So randomization has to be in place. Independence has to be there. That means our sample size needs to be less than 10% of the total population. Well, that's where things change, because if we're dealing with proportions, we're dealing with our NP rules. Remember, we need at least 10 successes and at least 10 failures, or at least 10 things from each of the categories. Well, with quantitative data, we don't have categories. We don't have a P. There's no proportion to deal with here. So we can't use our NP rules to determine if our sample is large enough. We've got to have something else in place here. So for quantitative data, our sample size being large enough, usually as a rule, since there's not a for sure way to tell, usually about 30 is what we go with. So if your sample size is 30 or larger, you're good to go. If it's not that big, then you need to be told it is coming from a normal distribution, because remember, if you are sampling from a normal distribution, the sample size does not matter. All right, so there is a rule that enables us to say that that is a large enough sample, and that is called the central limit theorem, but I am going to discuss that in another video because it needs some more attention than just that. So for now, just operate under this idea that, okay, how am I going to be able to tell if my sample is large enough? Well, for your problems that you don't have bigger than 30, then you're going to have to be taking it from a normal distribution. All right, and of course we have equations here or formulas to find our standard deviation for quantitative data, just like we do for categorical data. For quantitative data, our formula looks like this. All right, for standard deviation, we have to have an estimate or a known standard deviation to begin with, because we're just going to divide that by the square root of my sample size. So you have to be given a standard deviation to begin with that has been estimated through gathering of data up until this point. So just know that going in. All right, so as we move through here, I think that's all for this video, and then I'm going to work some examples for you in the next videos.